Hi, welcome everyone to the AMC 8 review session, part 2. Today we're going to cover the problems 16 to 25, I think. So yesterday we finished review of problems 1 to 15. With us today, Hari, Anusha, Agastya, Trisha, Avisha, and Dr. Sripriya Raman. So let me just introduce Hari and then he can introduce the rest of the panel. Hari Surnedi is a high school senior with a passion for helping and teaching. He's involved in a lot of things, including EMT, volunteering at the hospital, North-South, tennis, Science Olympiad, 3 honor societies, 2 of his own clubs, and much more. He's a coach for North-South and a student lead for the Math Magic team. Dr. Sripriya will share some more about the Math Magic team at the end of the presentation. If you're interested, you can also participate in that. Where he has set up and taught live solving sessions, helped with the question bank, and coached the Wise and Well program. And he would like to be an orthopedic surgeon. Hari, over to you.
Hey guys, thank you for rejoining. We had a pretty productive session last week, and we intend to do the same today. As you can see, we have some similar faces. Agastya and Anusha are here. But we have a couple new faces. First, I'd like to introduce Mrs. Dr. Sripriya Raman. She's our head, and she's a great leader, so thank you so much for helping us. Next, we have Trisha Kapolti and Avisha Kapolti. Trisha is a sophomore in high school. She's a 3-time AMC qualifier and has attended math counts and science school at the national level. She took AP Calculus BC in 8th grade and is involved in a lot of STEM clubs. In her free time, she likes watching movies and playing with her family and siblings. Avisha is an 8th grader that is currently taking Calculus BC and loves competition math. She placed second in the Math B1 at Nationals in 2016 and is also involved in science. She loves teaching and has great interest in math. I think with that, Anusha, would you like to do number 16?
Yes, thank you. So I'm Anusha. I'll be doing just number 16 today because our last session went overtime. So let's begin. 4 numbers are written in a row. The average of the first 2 is 21, the average of the middle 2 is 26, and the average of the last 2 is 30. What is the average of the first and last of the numbers? So in a problem like this, let's start by summarizing all the information that we have. So I'm going to set up some variables. So we have 4 numbers written in a row. Let's call those A, B, C, and D. The average of the first 2 is 21. So average is always the sum divided by the number of numbers. Basic middle school concept, elementary school concept. So we have A plus B divided by 2 is equal to 21. The average of the middle 2 is 26. And the average of the last 2 is 30. So C plus D over 2 is equal to 30. So those are the 3 equations that we can set up from the givens in this problem. So my first reaction upon seeing these equations is to try to manipulate them, is to try to solve for certain variables and start substituting things. But in a competition like the AMC 8, there's always a shortcut to our traditional algebra method. So we need to take a step back here and see if we can do something a little bit different to save some time. So the question is asking, what is the average of the first and the last of the numbers? So what we need is, we essentially need A plus D over 2, the average of the first and the last numbers. We are given in a single equation A plus B over 2 and C plus D over 2, but we're not given any singular equation with A and D in the same expression. So let's try to combine these. Let's try to combine these 2 equations. If we combine them, let's say we did A plus B over 2 plus C plus D over 2, that will give us A and D within the same equation. However, we just don't need A and D in the same equation. We specifically only need A and D in the same equation. So we need to find a way to get rid of this B and this C. Let's rewrite this. We have A plus B plus C plus D over 2. That's fraction addition. Our denominators are the same, so we can just go ahead and add the numerators. We need to figure out a way to get rid of B plus C over 2. Luckily for us, the problem gives us that exact expression. We are given that B plus C over 2 is equal to 26. Great, that makes our job a lot easier. So we can go ahead and write A plus B plus C plus D over 2 minus B plus C over 2. And that should give us A plus D over 2. Using what we're given in the problem, let's try to solve this out. So we can split this up again into A plus B over 2 plus C plus D over 2 minus B plus C over 2. What I did was I just split this right here, split the two fractions. So I split this fraction into two separate fractions, A plus B over 2 and C plus D over 2, and then I subtracted B plus C over 2. A plus B over 2 is 21. C plus D over 2 is 30. And B plus C over 2 is 26. So when we do that, we end up with an answer of 25, which is option choice B. So this should give us A plus D over 2, which is exactly what we need.
I guess some people were having some problems understanding how you were able to combine both of the expressions, allowing you to find the average of the total. So if you could just revisit that concept, that'd be great.
Revisit, can you repeat that one more time?
How you got A plus B plus C plus D all over 2.
Oh, sure. So let me make some more room here. So people were wondering how I got A plus B, how I was able to do this. And the way I was able to do that, combine them into a single expression, is that we're given A plus B over 2, and then we're given C plus D over 2. If I want to combine them, if I want to add them together, we can add them together like we would any other fraction. If the denominators of the two fractions are the same, I can go ahead and just add the numerators. So that's A plus B plus C plus D, and then I can set that all over 2. So it's like the same thing as saying 3 over 6 plus 1 over 6. I can keep the denominator the same and just add the numerators. It's the same thing. We're just dealing with letters and variables here.
Anisha, and the reason you decided to do that is to make use of all information, right? Like, because then because you are given A plus B by 2, you're given C plus D by 2, you're given B plus C by 2.
Right.
And you're asked to do A plus D by 2.
Right. So by combining A plus B over 2 and C plus D over 2, and then getting rid of the B plus C over 2, we're left with A plus D over 2, and we use all the information given in the question.
I think with that, we can move on to the next question. So
One other way, if you cannot think of this, is you can just choose examples, in the exam, like if you're not able to come up with a proof way, right? Like you can choose to have examples at two numbers that have an average of 21, two numbers that have an average of 26.
Exactly.
It should still hold good.
Yeah, if you're stumped, you can always try it by trial and error, substituting real numbers. But again, it's a math competition that relies on speed, so this would probably be the fastest one.
Thank you.
I think
And
the other questions were asking, why did you do everything over 2 for the average, right? So I guess they're not asking for the average of 4. It's like just the first and last. So that's why she took all of them and then subtracted the middle to just leave with the last, first and last.
yeah, exactly. So I just like combined these two fractions, and that would keep the denominator at 2. The denominator wouldn't change to 4 because I'm just adding the fractions.
Yeah, I think for the sake of time, we may have to move forward. I'm glad that we have many questions, so students are thinking about it. So maybe at the end of the session or tomorrow, try to do it on your own. Then you will figure out why we are doing it this way and why it doesn't work the other ways that some have suggested.
Yeah. And with that, I'll pass it on to Avisha. Thank you.
Okay, hey guys, I'm Avisha and I'll be doing problems 17 through 19. So problem 17 is if n is an even positive integer, the double factorial notation n double factorial represents the product of all even integers from 2 to n. For example, 8 double factorial equals 2 times 4 times 6 times 8. And what is the units digit of the following sum? So like is 2 double factorial plus 4 double factorial plus 6 double factorial all the way to 2022 double factorial. So basically, I'm just going to write a general rule for all double factorials, and that's equal to n times n minus 2 times n minus 4 all the way 2 times 2, because that's the smallest even divisor for all even integers. So now we're going to make a little chart. 2 double factorial is just equal to 2 because that's the only even divisor. 4 double factorial will be equal to 4 times 2, which is equal to 8. 6 double factorial is equal to 6 times 4 times 2, which is equal to 48. 8 double factorial is equal to 8 times 6 times 4 times 2, which is equal to 384, I believe. Wait, that's equal to 384, yeah. And then we have 10 double factorial, and this is where you'll notice something. You have 10 times 8 times 6 times 4 times 2, which is 3840. And so you'll notice that this ends in 0. And then let's just do one more so that you'll realize that from now on, all of the integers will end in 0. Because this will just be a big number that ends in 0. And so up to 2022, because there's always going to be a 10 multiplied by it, it's always going to end in 0. So the only units digits that we actually care about are 2, 8, 8, and 4. So if we add those up together, 2 plus 8 plus 8 plus 4, that is equal to 22. And they're asking for the units digit of the sum. So this is the actual sum of the units digits, but they're asking for the units digit of that, which is 2. So the answer is 2. Are there any questions?
There is one step you don't have to do the entire multiplication. Like if you don't want to do to save time, like Anusha said, this is a time sensitive test. So
yeah, if you want to save time, which you do, then you can just look at them and then you can just multiply it out in your head and you don't have to write out the full number and you can just like see the unit digit.
Unit digit. So for 8 double factorial, all you need is the 4, right?
Yeah.
You don't need to calculate is it 384 or 364 or whatever.
Yeah, you don't need to. I just did that for the sake of this problem.
Right, right. But once you understand the concept, that will give you some extra time.
Yeah. And you don't have to write out all the numbers either. You can just start with 2 and then you'll know that you have to multiply by 4 for the next one and then multiply by 6 for the next one. And so on.
I think one more common question that people had was, why exactly did you add the units digits of those numbers?
Oh, because whenever you're adding numbers together, you always start by adding the units digit, and because they're asking for the units digit of the following sum, you only need to find the units digit, which is the last digit of the number.
Exactly, yeah.
Are there any more questions?
Doesn't seem to be any more questions. So I think if everyone's good, we can go on.
Avisha, can you just quickly explain what n double factorial means?
Okay. So
that's the main concept of this question.
Yeah. So basically, you're just going to be, it's going to be like factorial, except instead of multiplying the number and then all the numbers below it, you're going to multiply all the even numbers below it. So it'll be n, and then the next even number that's less than n would be n minus 2. and then you'll subtract 2 from that to get n minus 4, and then you'll just keep on subtracting 2 until you get to 2. So you'll start from n, subtract 2, and then multiply that by n, and then multiply that by n minus 4, and then multiply that by n minus 6, and so on, depending on what the number is.
Thank you. And n has to be an even number in that case, right, for double factorial?
Yes.
Thank you. Okay, I think we can move ahead.
Actually, if I may just say, it does not have to be an even number.
No, it does, because in the problem it says from
No,
2.
the problem, but like an actual double factorial, it's like if it's an odd number, it's just all of the odd numbers multiplied.
Oh, really? Okay, that's good to know.
Yeah,
Okay,
it's just the one that has the same parity. So like if it's even, it's even. If it's odd, it's odd.
okay. Thank you, Trisha. And on the same note, I don't know if you know, I don't know, is there a triple factorial, and what does that mean? I think somebody asked that. I don't know. Or maybe I'm making it up. Okay, so a 3 factorial would be 3 times 1, 5 factorial will be 5 times 3 times 1, 7 double factorial would be 7 times 5 times 3 times 1, is that right?
Yeah, it's just every time you add a factorial, you're really just increasing the number that you're subtracting.
Okay, got it.
So I think we can go on.
Okay, yeah. So problem 18 is the midpoints of the 4 sides of a rectangle are -3, 0, 2, 0, 5, 4, and 0, 4. What is the area of the rectangle? So whenever they give you coordinates, you always plot them. So let's do that. So the first one is -3, 0. The next one is 2, 0. 5, 4. And then 0, 4. So we end up with this like parallelogram-like thing, but then these are all the midpoints of the sides. And so that means that this right here and this right here, if we connect them, then these would be the lengths. For example, so if I sketch out the rectangle, then this is what it would look like. And then this is the midpoint. This is a midpoint, this is a midpoint, and this is a midpoint. And so now I'm going to draw this rectangle like right side up so that there's no slant to it. And then I'm going to write the coordinates in. So right here we have -3, 0. Here we have 2, 0. Here we have 5, 4. And then here we have 4, 0. Now if you connect these together, then you'll notice that this length right here is the same as the length of the rectangle. And then this length right here is the same as the height. And in order to find the area, you just need to do length times height. So we can easily find the distance using the distance formula. So for example, if we have 2 coordinates, x1, y1, and then x2, y2, then to find the distance between them, the formula is the square root of y1 minus y2 the whole squared plus x1 minus x2 the whole squared. And they're interchangeable because they're squared. So if it's negative, then it'll still become positive. So now in this case, we need to find the distance between 4, 0 and 2, 0. And
Avisha, the coordinate is 0, 4, not 4, 0.
I just realized that it's 0, 4 and 2, 0, and then -3, 0 and 5, 4. So let's start with 0, 4 and 2, 0. So that means that it'll be the square root of y1, which is 4, minus y2, which is 0, the whole squared, plus 0 minus 2. So that is equal to the square root of 16 plus 4. And so that's equal to the square root of 20. So this height of the rectangle is square root of 20. And then if we take the distance between -3, 0 and 5, 4, then that will be y1 minus y2, which is 4 minus 0, and then plus 5 minus -3, the whole squared, So this will just become 5 plus 3, which is 8. So that'll become square root of 16 plus 64, which is equal to the square root of 80. So this is square root of 80. So now we know that the height is square root of 20 and the length is square root of 80. And the area of a rectangle is just length times height. So we can just multiply square root of 20 times square root of 80, and that's square root of 1600. So that is equal to 40, which is answer choice C. Are there any questions?
Someone just pointed out that you could use Pythagorean triples. So if you wanted to explain it that way, you could too.
Yeah, so if you wanted to find, I'm pretty sure what they mean is if you wanted to find the length of this, then it would be 5, and then you would get a 3, 4, 5 triangle. Wait, no, I don't think that'll work, because then the area will be 48. You can't assume that this would be 3 and this would be 4. So I don't think you can, unless there's a way that I don't know, I don't think you can use Pythagorean triples for it.
Okay. And then for those of you guys that don't know the distance formula, you can always do it just by looking at triangles, right? And figuring out the lengths like that. Which is pretty much the same thing as the distance formula.
Yeah, but the distance formula is a good thing to memorize, so it'll be really good to memorize that.
Yeah. I guess some people were asking you to explain it with the triangles. I mean, it's the distance formula, but if you could just show them the triangle, that'd be cool.
Okay, so basically, can you go to the next slide? So if we have this right here, 0, 4, and 2, 0, and we want to find this length, then you could use it like this, I think. Let me get the other coordinates. 5, 4, and -3, 0. So basically, this, you could find the length of this right here, and the length of this is equal to that, which is 5. And so, yeah, so you can use Pythagorean theorem for this. So if this is x and this is y, then x squared plus y squared is equal to 5. And so, yeah, I'm not totally sure how to explain this if someone else wants to.
Sure.
Other than Pythagorean, I don't know if this is how she explained it, but can you go to the first slide? Yeah, the one. So the midpoints, you can see the midpoints area, that's half of the area of the rectangle. So if you use Shoelace Theorem with the coordinates, which Avisha can show you if needed, you use the Shoelace Theorem and then you just multiply by 2. That's a really, really, really easy way of finding the area of the rectangle without even graphing it, because if you have the midpoints of a square or rectangle, you know that the area of that is half of the whole thing of the what's it called, the figure, or like the rectangle inside enclosed by the midpoints is half of the area of the rectangle itself.
Cool. Let's do it because a lot of people are asking.
Yeah. So Avisha, you can show them, right?
Yeah. So if we go to the next slide, then, so the Shoelace Theorem is where we have this figure right here. And so you just list the coordinates. So the first one will be 0 to 4, 5, 4, 2, 0, and then -3, 0. And then you always have to make sure to list the first coordinate again. And then you're just going to cross this over right here like that, and then cross this one over like this. And then, so now you're going to multiply 0 and 4, which is the first cross, and that's 0. Multiplying 5 and 0, which is the next cross, that's also 0. 2 times 0 is 0, and then -3 times 4 is -12. And then if you go to the next side, then 4 times 5 is 20, plus 4 times 2 is 8, and then plus 0 times -3 is just 0, and then plus 0, that's equal to 28. So we have 28 and -12. If you add all of these together, then it'll become -12. And then you subtract the bigger number minus the smaller number, so you get 28 minus -12 is equal to 40.
So yeah, that's pretty neat and pretty cool to memorize. So, but for the sake of time, let's move on, guys.
Okay, so problem 19 is Mr. Ramos gave a test to his class of 20 students. The dot plot below shows the distribution of the test scores. Later, Mr. Ramos discovered that there was a scoring error on one of the questions. He regraded the tests, awarding some of the students 5 extra points, which increased the median score to 85. What is the minimum number of students who received extra points? Note that the median test score equals the average of the 2 scores in the middle if the 20 scores are arranged in increasing order. So the first thing that you should know is that the median in this case will be the average of the 10th and the 11th number. And so that will be the median. The average of the 10th and the 11th. So in order for that to be 85, then either the 10th and 11th both have to be 85, because 85 plus 85 over 2 is equal to 85, or it has to be the 10th one is 80 and the 11th one is 90. There's no other possible way. It can't be like 75 and 95, because there are still going to be people with 80 and 90 in between and stuff, because we want to move the minimum amount of people. So let's consider this first case here where we want the 10th and 11th people to have 85 as their score. So as you can see right here, if we count from the left, and I'm just going to split this in the middle, this side right here has 7 and this side has 13 people. And so we want to switch this so that there are 3 more here, so that there's going to be the 10th person. So if I move 3 from the 80, because they get added 5 points, if we move 3 from the 80 and then add it on to here to give them 3 right here, then that'll become 10. And then this, you're adding 3, so that'll also become 10. And so now if you see, then that means that this is the 10th and then this is the 11th, and that does not work, because that means that the mean will be 82.5, not 85. So we have to move one more person, just so that the 11th score can also be on this. Oh, the 11th score can also be here, so that here is both the 10th and 11th, so that the average will be 85 plus 85 over 2, which is just 85. And so the minimum is 4. But then if we also look at the second case, if you wanted to use that, then you would see that you have to get 80 and 90, which means that there should be no 85s in between. And so that means that you would have to move all of the 85s over, which gives you more than 4, and they're asking for the minimum. So that means that 4 is the minimum. Are there any more questions?
There is one question asking if you could explain how you got the 85, 90, and 90 and 90 again.
Oh, okay.
Yeah.
So basically, in order for the average to be 85, whenever there are 2 numbers, then either they have to be the same or they have to be an equal distance from 85. So for example, if you want it to be 85, then you can have them be the same, which is 85 and 85, or you can have them be like equidistant. So if you take out 5, because that's the amount of points that get rewarded, then you get 80 and 90. But then you could also do 75 and 95, but in this case, that'll result even more students getting extra points, but they're asking for the least amount. So 80 and 90 is like the second case that we can consider.
And then, yeah, and then there's one more question. Can you explain why you specifically were looking at the 10th and 11th?
So because they want the median to be 85, and in a class of 20 students, the median is going to be between the 10th and 11th, because whenever there's an odd number, it'll just be that over 2 plus 1, like the total number over 2 plus 1, and that will be the median. But in this case, there is an even number, so you have to do that and the 1 over 2. And so that in this case, 20 over 2 is 10, and then 20 over 2 plus 1 is 11. And so you have to take the median of those two because there's an even number of students in order to find the median.
Perfect. One more question that people had. Could you just re-explain the why you were moving the 80s to the 85s?
Because we want 85 to be the median, and we want it to be 85 and 85 as the 10th and 11th. So we need to get more people to have a score of 85. And so in order to do that, we need to, because they're adding 5 extra points, we need to go from 80 to 85 because they're adding 5 extra points.
Cool. So far, there's no more questions, so I think we're good to move on, unless anyone has anything to add.
Okay, thank you.
So let's keep going then. So number 20, guys. So the grid below is to be filled with integers in such a way that the sum of the numbers in each row and the sum of the numbers in each column are the same. Kind of like a magic square, if you guys have ever done that. 4 numbers are missing. The number x in the lower left corner is larger than the other 3 missing numbers. Okay, so x is greater than this, this, and this. What is the smallest possible value for x? So I guess let's first find that sum, right? The sum that that all of the rows and columns have to equal. So we can do this, which will be minus 2 plus 9 plus 5, which is going to be 14 minus 2, so 12. So we know that our sum will be 12. And if you wanted to check it this way, right, 5 and 8 are 13 minus 1 is 12. So now that being said, we can use this to our advantage and put each one of these 3 other missing numbers in terms of x. So let's find this one using this column. So we know that negative 2 plus something, right, something in terms of x, plus x is equal to 12. So if we solve for this something, we're going to get 12 plus 2 minus x. And that means this is going to equal 14 minus x. So let's write that in there, 14 minus x. If we do that with this bottom row, right, we can find this one. Let's see, x plus something plus 8 is going to equal 12. And if we do the same thing, solve for it, we're going to get 12 minus 8 is going to be 4. And then we're going to subtract the x's onto the other side. So we're going to get 4 minus x there. And then finally, we can use this to figure out x, the missing number in terms of x there. So 4 minus x plus something plus 9 is going to equal 12. So if you subtract the 9, you're going to get 3. but you have to subtract the 4 as well and then add the x. So that's going to equal, I'm going to move the x here, this is going to equal negative 1. So we're just going to subtract the 1 there. So boom. Now we used pretty much all of the first information that we had. Now, don't get stuck here. Let's look at what they give us more, what they tell us more. They tell us that the lower left corner, so this x, is going to be greater than the other 3 missing numbers, right? So what do we think of when we see that? We immediately think inequalities. So x is going to be greater than 14 minus x. X is going to be greater than x minus 1. X is going to be greater than 4 minus x. If we solve these out, we can find constraints for x. So let's do that. If we add this x onto the other side, we get 2x is greater than 14, and then x is greater than 7. If we subtract an x in the second one, we get 0 is greater than negative 1, which is true, right? 0 is greater than negative 1, but it doesn't really help us because it doesn't give us a constraint. And the bottom one is, we kind of do something similar to the top. We add the x onto the other side, making 2x greater than 4, which leaves us at x is greater than 2. So now we have our constraints. I'm going to draw a number line just so you guys can visualize this. But during the test, it'd be easier if you just thought about it, or rather it would save more time. So if you visualize this number line, right, we know that our constraint here tells us that x can't be 2, but it has to be greater than 2. And our constraint up here tells us that x can't be 7, but it has to be greater than 7. So I guess none of this can be true, right? Because x has to be greater than 7. So if we look at our answer choices, what numbers are greater than 7? We see 8 is greater than 7 and 9 is greater than 7. And the question's asking for the smallest possible value of x, which means 8 is our answer, so D. Any questions?
I would just give it another minute. So someone asked, could you substitute x with the options given?
Let's think about this. I guess you could, yeah. Once you figure out these, you can plug in the x's. But to be honest, if you can do this and this is obviously not going to give you a constraint, right? Because everyone knows that if you take one number and subtract 1 from that number, the number that you subtract 1 will be less. So if you take 3 and you minus 1, 3 is going to be greater than 2. So this isn't going to tell you much. So you're really looking at this and this, and really eyeballing it, you'll notice that x has to be greater than 7, and you're going to choose D. But if you want, you can plug in chug as well.
Yeah, that was well done. I think I would move on.
Okay. So let's do this. Steph, as in Stephen Curry probably, scored 15 baskets out of 20 attempts in the first half of the game, and 10 baskets out of 10 attempts in the second half of the game. So Steph was on fire at the second half of the game. Candace, on the other hand, took 12 attempts in the first half and 18 attempts in the second. In each half, Steph scored a higher percentage of baskets than Candace, but surprisingly, they ended with the same overall percentage of baskets scored. How many more baskets did Candace score in the second half than in the first? So something that pops up to me first, right? They have the same overall percentage of baskets. So that means their total fractions are going to equal, right? If you look at how many attempts they've made, it's really convenient that they're the same number when you add them together, right? 20 plus 10 equals 30, and 12, not times. 12 plus 18 is 30, right? So you're going to know that since their overall percentages are the same, and Steph makes 25 out of the 30 shots that he took, Candace is also going to make 25 of the 30 shots she takes. But it matters how she takes it, right? And that's where we come back to this part of the question, where it says that Steph scored higher in each half than Candace did. So again, inequalities, they really loved them this time. So we can write 15 over 20 is going to be greater than, let's call the number of shots that Candace made in the first half X, meaning that since Candace had to make 25 shots in total, she's going to have to make 25 minus X shots in the second half, right, to add up to 25. So 15 over 20 is greater than X over 12. And the second inequality we can make is 10 over 10 is greater than 25 minus X over 18. So again, solve them out. Let's see. We know that we're going to have to multiply by 15. So 12 times, multiply by 12 on both sides. So 12 times 15 over 20 is going to be greater than X. 20 is the same thing as 4 times 5. 12 is the same thing as 4 times 3. 15 is the same thing as 5 times 3. So 4 cancels, 5 cancels, and you are left with 9 is greater than X. Cool. One constraint. Now let's do the second one. We know that 10 over 10 is 1, right? So let's just simplify that and say it's 1. So this is what our thing looks like now. Just for the sake of space, we'll go down there. So now if we multiply by 18 on the other side, you can have 18 is greater than 25 minus X. If you solve for X, right, by adding X to this side, you're going to get X is greater than 25 minus 18, which is 7. Cool. So now we have two constraints. We know that 7 is less than X, right? We know that X is less than 9. So now that seems like we have a lot of options until you realize that you can't make half a basketball shot, right? It either goes in the basket or it doesn't. So the only option you have is 8. That means our answer is 8, right? No, it's not. Because, my friend, you have made the fatal flaw of not answering the question. Because the question asks, how many more baskets did Candace score in the second half than in the first? So this is the number of baskets she scored in the first half. You have to subtract that from 25 to get your second half. So 25 minus 8 equals 17. And 17 minus 8 equals 9. So she makes 9 more baskets in the second half. So the answer is C. Any questions?
I'm not really seeing any. How do you know she scored 8 in the first half?
So we strategically set our X as the number of shots she made in the first half, right? So once we solve for X in the way that we did using our inequalities, right, we're going to get that X equals 8. So again, you cannot have 7.2 of a basketball shot. That's just not how it works, right? So you can either in that number line, which means we're really only looking for the integers between 7 and 9, which is 8. I guess a joke would be 9 was afraid of 7, or whatever. Nothing. Never mind. I forgot the joke. Yeah. 6 was afraid of 7 because 7, 8, 9. But any other questions?
Aside, we have, how did you get 25 minus x, and why did you say that 18 is greater than 25 minus x?
18 is greater than 25 minus. Okay, so we know that she made it.
One more. Why did you say that 18 is greater than 25 minus x is equal to x is greater than 7? Sorry, I did not understand that at first.
So if you add x, right? If you add x to both sides on this, and you subtract 18 on both sides, you will get something that looks like this. You'll get 18 minus 18 plus x is greater than 25 minus 18 minus x plus x. So the x's will cancel, the 18's will cancel, and then you'll be left with x is greater than 25 minus 18, and 25 minus 18 is 7. So we just solved it out. Actually, for those of you that are wondering if there's a faster way to solve it, I do not know a faster way. So if anyone on the panel does know a faster way, go ahead and say it. Otherwise, I think we should keep going. So let's go on to number 22. A bus takes 2 minutes to drive from one stop to the next and waits 1 minute at each stop to let passengers board. Zia takes 5 minutes to walk from one bus stop to the next. As Zia reaches a bus stop, if the bus is at the previous stop or already has left the previous stop, then she will wait for the bus. Otherwise, she will start walking toward the next stop. Suppose that the bus and Zia start at the same time toward the library, with the bus 3 stops behind. After how many minutes will Zia board the bus? So let's just keep track of time and see where Zia is relative to the bus. So in the first 5 minutes, right, Zia will go to the next stop, while the bus will drive from one stop to the next in 2 minutes, wait there for 1 minute, right, and go to the next stop, arrive at the next stop in this next 2 minutes, right? So the bus still needs to wait that 1 minute. Keep that in mind. So since the bus is not right here, right? Because Zia is here now, right? Since the bus is not here, Zia is going to continue moving to the right, closer to the library, taking another 5 minutes to get there. So in that time, what will our bus do? Our bus will then wait 1 minute, travel for 1 minute and for 2 minutes, wait for 1 minute, and then right at that 5 minute stop, it'll be on its journey. It'll have spent 1 minute on its journey toward the next stop. Okay. So again, now Zia is here, right? And we need the bus to be here for Zia to wait because Zia is kind of impatient. So Zia doesn't do that, so she continues to walk. So Zia takes another 5 minutes to get to the next stop, and the bus is trying to run after Zia, I guess. And it spends 1 minute going to the next stop, 1 minute waiting at the next stop, 2 minutes getting to the next stop, and then 1 minute waiting for the next stop. So those of you that didn't follow, 1 minute wait to get to the next stop, this stop. 1 minute waiting at the next stop, 2 minutes getting to the next stop, and 1 minute waiting at the next stop. So that's 5 minutes. So it checks out. So where is Zia? Zia is here, right? And she needs the bus to be here in order for her to wait. And guess where the bus is? Big bus is right here. So Zia is going to wait for the bus. So is our answer 15? No. We're keeping track of time here, right? We still need the bus to get to Zia. So in order to do that, the bus needs to travel another 2 minutes. And then after those 2 minutes, Zia can get on the bus. So if we can add up the rest of the time, you get 5, 10, 15. 15 plus 2 is 17 minutes. So 17 minutes for Zia to get on the bus. Any questions?
So far, I'm not seeing any, but I would give it another minute or so. Yeah, but overall, that was pretty good. I think we're good to move on.
So I guess there was one question. Why does Zia not move again? Well, on that last point, right? Zia, I'll use it in yellow, was here. Let's see. Got a nice dress on. Okay. Zia is right there. And where is our bus? Our bus is right here. So since the bus is at the previous stop, as it says here, she will wait. She will wait for the bus. And that's how you know she's not going to keep going. I added the 1 plus 1 plus 2 plus 1 to show you that when during this third 5 minutes, right? What we see is the bus will travel to the next stop for 1 minute, wait there for passengers to get on for 1 minute, travel to the next stop after that previous stop, right? For 2 minutes, so that's 4 minutes total, and then wait at that one stop for 1 minute. Or rather, it was this 5 minutes, but yeah, you got the point. And other than that, I think we can keep going. So Trisha, you got it.
Hey guys. So last 3 problems, let's get them over with. So this is number 23. A triangle or circle is placed in each of the 9 squares in a 3x3 grid. Shown below is a sample configuration with 3 triangles and a line. So here are 3 triangles right there. How many configurations will have 3 triangles and a line and 3 circles and a line? Okay, so a sample of, I'm just going to draw a sample of what they're kind of asking. So like 3 triangles, 3 circles, and then like triangle, circle, triangle, something like that. Or it could be in the same, this is in the same column. It could be like triangle, 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 circle, 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 triangle, circle right there, right? But there is another thing we have to kind of consider, which is like the diagonal here. And if we have a diagonal like that, we can see that you can never get, if we have the 3 triangles in a diagonal, you can see that you can never get like a circle, a row, a line of circles, because wherever you put it, like even if I fill the whole thing with circles, you're not going to find a line of circles. So just so that we have that clear. And so there are 2 cases. This is one case, and then this is another case where the lines of the triangles and the circles are in a row or they're in a column. You can't have both, as we saw like with the diagonal thing. It's kind of the same thing. But I hope you can see that it's like basically this is symmetric. So if you count the number of cases for this case, the number of ways you can arrange something for this case, multiply it by 2, you get it for the column. I mean for the rows. So I'm gonna calculate it with columns right now, and then just multiply it by 2. So there are 3 columns, right? We have, and we want to have a line of triangles and a line of circles. So these triangles can go in any of these 3 columns, right? So there are 3 ways for that. And then let's say they choose to take this column, okay? Now we have two ways for the circles to choose their columns. So we're gonna multiply that by 2. And the circles choose this column, okay? So now there are 3 spots on the last column. And how many ways can a triangle or a circle fit in there? That's just 2 times 2 times 2, 8. Because you can put either a triangle or circle no matter what, because we've already fulfilled our conditions of having a line of triangles and a line of circles. So you're going to multiply that by 8, and we get 48. And no, an AMC 8 problem will not be this easy, especially in like the last 3 problems, so we're not done yet. You are overcounting. So we have to recognize that we're overcounting here, because when we have, say, triangle, 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 circle, 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 and then we have, let's say, the way we're overcounting is if we have another triangle, 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 because what we have to notice here is that this is when we're choosing the first line of triangles in this column. But what if we choose the first line of triangles in this column, and then the circles choose this column, and then we have another line of triangles here? Yeah, so what if that happens? So that's why we're overcounting. And can you see my writing on the screen? Because I can't for myself.
Did you erase any of it?
No, because on my device I can see my writing.
We were able to see it up until now, Trisha, up until the last one.
Yeah.
I think you erased it.
No, I can see it. I can see it on my device.
I think it's working now. Oh, no, it's gone.
Yeah, I have to, let me do something real quick. Can you see them all now? I just like undid and redid them, so.
Yeah, it's popping up.
Okay, let me explain that thing one more time.
And they're gone.
Oh my gosh.
Is there a way for you to just refresh? I can refresh on my end too.
Yeah, can you try to refresh and see if it's there? Okay, there we go. It's all there. Okay. So basically what I was trying to explain is that in this, so on the blue on the bottom here, right here. So what we're doing here is that we chose the first line of triangles on the first column of triangles on that side. But what if we actually chose it on this side, and then we choose the circles to be on this side, and then there's just another line of triangles. It's the same thing. You're just like you're just choosing it in a different order, but you're counting them separately. So you have to you're overcounting in the sense right now. So basically this will also happen when you have like circle, 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 triangle, 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 and another circle, circle, circle. So these are the 2 ways they overcount when you have 2 of the same lines and 1 of the other. And we just have to remove one of the countings. So the number of ways we can arrange this is 3, which is just 3 factorial over 2 factorial, because like you can have the circles here, circle, triangle, circle, 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 triangle, or triangle, circle, circle. And there's 3 ways to do
3 ways to arrange this as well. So when you add those together, you have 6 overcountings, and you subtract that to get 42. And so that's just for one case. So don't like forget that you have the whole rows to count as well. So you're just going to do 42 times 2, which is 84, which is our answer. D.
Someone asked if you could explain the overcounting thing one more time.
Yeah. So basically, I'll just go to the next slide so I can just show. This is something that if you don't get now, I think you just have to keep on thinking about it. But yeah, I'll just go ahead and explain it one more time. So we have already chosen a column of triangles and a column of circles. Let's say that's the leftmost, then the middle, and then we have to choose for the rightmost. And let's say the rightmost that we choose is triangle, triangle, triangle. Basically, this is our configuration now. But now let's say that we actually are choosing the rightmost column as triangle, 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 the middle as circle, 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 and we have the leftmost to choose now. And then the leftmost, I'm choosing triangle, triangle, triangle. So like, let me write it like that. So like you can kind of see that the order that we're writing them is different, but the end result is the same. So like we're overcounting it because we only need to count the first one. We don't need to count the second one. And when you see how many of these you're when you see that like you're overcounting, you just have to get rid of them. And so there's 3 of this because you can arrange this as circle, triangle, circle. Wait, sorry. You can arrange this as triangle, circle, triangle, 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 circle, or circle, triangle, triangle. Those are the 3 ways, and then you just do it with the 2 circles and 1 triangle as well. And I saw the question where it says, how do you not overcount? Like, I think this overcounting, it's nice because you get to see like the way you do it, it's fine if you overcount. You just have to be careful of how to like catch it and then not. I'm not completely sure how you do it without overcounting. It's just probably have to like list it all out or something. Yeah.
Yeah, and then she got that -6 because she's subtracting the 6 she overcounted. But I think those were all the questions. Let's keep going.
Yeah. Okay. So this is a really cool question. Problem 24. The figure below shows a polygon ABCDEFGH consisting of rectangles and right triangles. I labeled these and I color coordinated this. Like the points were labeled, but I drew on top of it, so you didn't get that, by the way. When cut out and folded on the dotted lines, the polygons formed a triangular prism. Suppose that AH equals EF equals 8 and GH equals 14. So let's label that. AH equals EF equals 8, and then GH is 14. So this thing is 14. And so what is the volume of the prism? Okay. So I was really tempted to just go ahead and say ABHG was a square. And you'll find out that it is, but you just don't want to say that it is yet. So basically, first thing you have to do is know what a triangular prism is. So first of all, it's a right triangular prism because these are the triangles that are seen in like the layout is a right triangle, so it's a right triangular prism. And on this is what a right triangular prism looks like. I have corresponded the vertices to the vertices on the triangular prism. When you fold it, it's really hard to explain virtually because if I was like in person, I would have like cut out I strongly encourage you guys to do this, because when I was starting off, I would actually take like scissors to competitions, because I would cut out the paper or like rip the paper, label the points, and then try to make the shape, because it was so much easier to visualize that way rather than put it all in your head. So I recommend you guys doing that even now at home, like just with the paper, draw it out, do it, because that's how I solve these, because they're much easier to like find out and like see where they the vertices, when you like fold them, where they correspond to, because as you can see in a triangular prism, you only have 6 vertices. And here you have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. So 4 of these points will correspond to another point, which I would have labeled on here. So basically, I really recommend you guys to cut it out and then try it on your own for that. But this is what it will look like in the final. And so I've basically color coded which sides are the same. So so basically this J right here will correspond to J here. Same thing like that. And so we can see that this is the height, GF is the height, BC is the height, and so then you have everything else. And when you fold it, the key to finding is that when you fold it, FE right here E will go to G. Like when you fold it, those two vertices will converge. And so then that means that EF is equal to FG. So this is also equal to 8. So the height is equal to 8. Okay? So then again, also AB corresponds to BC when you fold it. So that means that AB is also 8. And so then HJ is 8. So then JG is 6, because if you just do 14 minus 8 for that. And then since it's a right angle, you can use the Pythagorean theorem to find that BG is 10. So, which is not very necessary. I'm just like showing you guys how to find the side lengths of each of the things. So BG is 10, this is 6, this is 8. And the volume of any shape, any 3D figure is 1/2 area of the base, which I'll capitalize as B. Because when you do area of triangle, it's like lowercase b, so area of the base times height. So the area of the base is this right triangle here for this prism, and that is going to be 6 times 8 divided by 2, area of a triangle. And then the height we have is 8 times 1/2 here, and you will get 192, I believe. So yeah.
Nice explanation. Let's give him a minute. You don't need to do the 1/2, is what someone has said.
Oh, sorry. One second. Yeah, it's just
It's just based on height, yeah.
Yeah, sorry.
You're good.
The base is the 8 by 10 rectangle.
No, it's the triangle.
The base is the 8 by 10. Wait. Okay,
If you set, so whenever you do a prism, right, volume, you can think of it as whatever shape it is stacked infinitesimally up to a point. So if you set your base as the triangle, you just have to multiply it by the height. So yeah, the base is the triangle. No other questions, guys? Well, you did explain it really well, so I don't see any more questions, so let's keep going.
Okay. So problem number 25, this was, okay, this was, to me, this was a lot easier than 23 and 24. So, and I'm like kind of upset with like the AMC writers, because they've started to like make the difficulties really randomized in the problems. Anyways, so a cricket randomly hops between 4 leaves on each turn, hopping to one of the other 3 leaves with equal probability. After 4 hops, what is the probability that the cricket has returned to the leaf where it started? Okay. So what we have to do is let's categorize this as start, and the actually, can we just move on to the next slide? I think we have the gist of the problem. I'll do it on the next slide. So let's do the start and the 3 other leaves, okay? And then we're gonna do the first hop, the second hop, the third hop, and the 4th hop. So this is what I'm kind of categorizing is the probability of the cricket being on the start on the starting leaf or the 3 others. We don't care about which of the 3 others it's on. It's just, is it on the 3 others or not? So after the first hop, it starts at the first leaf. So there's a 0 chance that it's at the starting leaf, because it has to hop away from the leaf. It doesn't stay at the same leaf. So there's a 1 probability. Obviously, probability always adds to 1. So we have 100% chance it's on the 3 other leaves. Okay, so no matter what other leaf it's on, it has a 1/3 chance of going back to the starting leaf on the second hop. So we're just gonna do 1 times 1/3 here, which is just 1/3. And then since probability has to add to 1, there's a 2/3 probability it's on any of the 3 other leaves. I'm not gonna go into the actual like calculating what probability on each leaf it is, because that's irrelevant. So then now we're gonna, because if there's a 1/3 chance it's on the start, it's not gonna be on the start again. So we just have to look at the 3 others. So there's a 2/3 chance it's on the 3 others on the second hop. So then you're just gonna multiply that by 1/3 to get 2/9, that it goes back to the first leaf on the 3rd hop. And then this is just a complement. And then you're gonna multiply this by 1/3 again to go back to see the probability goes back to the first one, because there's a 1/3 chance from any of the other 3 leaves that it will go back to the first one. So that's just 7/27, and that's our answer. This is 20/27, but that's what we want to find. Yeah, if you have any questions, just go ahead.
Can you explain the 3rd hop one more time?
Yeah. So from the second to the 3rd hop, or I can explain both.
Sure.
So it's basically the same thing we did. So you're from the first hop, you just multiply by 1/3 to get the probability it goes back to the first leaf. So that's the same thing we're doing for the second hop. So we're just, since there's a 2/3 chance, there's a 2/3 chance that it's on any of the 3 other leaves. And if it's on any of the 3 other leaves, there's a 1/3 chance it'll go to the first leaf, because there's a 1/3 chance from any of the other leaves that you're jumping to the first one. So you're just multiplying whatever probability you had before by 1/3 to get the probability that it just goes back, if that makes sense. Which I'm doing the same thing. You get 2/9 here. And just because probability always has to add to 1, you'll just take the complement of that, 1 minus 2/9, to get 7/9 that's on the 3 others. And then you do the same thing for 3 to 4.
And then, let's see. Could you explain that last bit about why you were multiplying 2/3 to 1/3 and 1/3 to 7/9?
Yeah. I think I just explained that, but I can say that again. So you're on the 3 others with a 2/3 chance. You're on the 3 other leaves with a 2/3 chance, and to go back to the first one, you have a 1/3 chance of hopping back to the first one. So 2/3 times 1/3 gives you 2/9, which is the probability that with the 2/3 chance you're on the 3rd leaf, on the other 3 leaves, that you go back to the first one. So you get 2/9. And then with the 7/9, it's basically the same thing.
Finally, is there an easier way or faster way that you see that you can do this problem?
I don't think so. I think this is a pretty quick solution for a problem like this.
Yeah, I can agree with that. So we do have about 7 minutes left. I know Sri Priyanti wanted to say a couple things. And then after that, we can open up questions for general things.
Awesome.
Auntie, you're muted, by the way.
Thank you, Hari. I just want to say thank you to all who volunteered. Hari, Agastya, Anusha, Trisha, and Avisha, thank you very much. You really did a great job, and this is really helpful for our families. And as always, thank you to Mr. Vinay for hosting the session for us on behalf of the webinar team and starting the session and being with us. And Mr. Vinay has helped us for multiple other sessions as well, including our AMI webinar that's going right now. There were questions about where to find the YouTube links of the videos. I had put it in the chat, and I think Mr. Vinay also put it in the chat. So if you cannot find it, just go to the North-South website's YouTube channel. You can just Google North-South YouTube channel, you will find it, and then you can look for the AMC 8 sessions. We had one last year. This is our second one. So you will find links to those. And we also had an Meet the Pro for math session last Sunday. And we had 4 panelists on that who have done very well in competitive math. And we had an invited panelist among them too, who writes questions for AMCs and AMI and even IMO, Math Olympiads. So if you're interested to view that, it's on the NSF website as well, North-South YouTube channel. That's all I wanted to say. And if you want to volunteer and be part of this wonderful group, we are looking for always parent and student volunteers of all caliber, like at least AMC 8 and higher level for our group. So if you're enthusiastic, confident, and competent, please reach out to us.
So I guess with those last 4 minutes, we can answer some general questions. What resources would you recommend is a pretty popular question? I would say AMC. What about you guys? What AMC? AOPS. Yeah, AOPS.
AOPS,
Auto
yeah,
problem
and just any previous problems, like you can find previous AMC 8, AMC 10, AMY, any problems like given by the MAA on AOPS, just using those is best. And there's books on AOPS too. They have written a lot of books for you guys.
Yeah, so that's good in terms of resources. And then additionally, to prepare, I would just say knowing your middle school skills really well, those math skills that you're taught in school, making sure they're really solid and memorizing some quick formulas that might help you. So as we saw through these problem solving sessions, distance formula pops up, probability pops up a lot, you know, some number theory, that would all be really handy so that you can get the problems done faster.
Yeah, another thing is like, don't worry about the grade you're in, right? Because the grade you're in and the math level you can be at are completely two different things. So.
And I just wanted to like give an example. Dr. Shripur was just talking about the writer for IMO. He actually started doing competition math in like 11th grade. So he started very late, but now he's one of the best like mathematicians and one of the best writers that International Math Olympiad has seen. So don't think about when you're starting late. It's just if you like it or not, and if you're really interested in it.
Yeah, and too early too. Too early doesn't exist. Yeah. So. Saw something here.
I see one saying, is it about speed or is it about problem solving ability? It's both. In these competitions, the problem solving ability and speed are both stuff you just need to work on with practice. And there's also a question saying, oh, I think Agastya answered this, but when and where can you attend the AMY? You have to take the AMC 10 or 12, and you have to sign up with your school, or ask your school to sign up, or any other outside organization that you know of. And then you have to answer a certain number of questions, and that's how you qualify for the AMY.
I think there's one question about whether you can take the test without your school offering it. I'm not sure. I know that some colleges can offer it.
Yeah, a lot of colleges do offer it. Like, you just have to look into it. And if your school doesn't provide the test, you can ask them to. If you have like a certain number of friends or something that want to take it, you can go and ask your school or a certain teacher. Your teacher can register you too for it.
You see a question that says, how many questions do you need to answer? It's just about how many you can answer. So pretty much get as many done as you can answer correctly. There's no
a lot of practice. So there's a question about how best to prepare for these tests. A lot of practice. Just being really solid with your skills, right? Not trying to memorize problems, but rather knowing how stuff works.
Yeah, I would agree with that. The more competitions you do, so make sure you do the North-South math Bs, like level 1, level 2, level 3, whatever is appropriate for you. That will prepare you for AMC 8. And, and then continue it beyond middle school as well. That's where the AMC 10, which is for 10th graders and below, AMC 12 is 12th graders and below, and AMY is for high school students.
I guess most of us can agree on this, but as long as you are doing this out of interest, the practice becomes fun. So even if you're not interested in now, just give it a shot, and hopefully you'll have a fun time. But yeah, with that, I don't really see any more questions. So if you guys have any last words that you want to put in, otherwise we can end the meeting.
For the question that if the school doesn't provide the test, I pasted a location. You can go to maa.org and search for the locations near you that offer the test. So you can actually sign up at those locations also. So, and for the last 3 years, actually, it was hosted online by AOPS on behalf of MAA. So the questions are prepared by the Mathematical Association of America, but just the online competitions were hosted on AOP's website. And then so the hosting locations actually participate. You sign up through your school, or you can look for one of the nearest location that you can participate from. All the best. And I think, yeah, so AMC 8 has been moved to January instead of November. So you can sign up for January 2023 when the registration is open. And thank you all for, thank you to all the volunteers who have given excellent solutions for the problems for AMC 8, and hopefully all the participants have now a better understanding of what kind of solutions you would have for the AMC 8, and all the best for next year.
Yeah, thank you so much, Vinay Uncle, for being here too, as well as Sri Priyanti. So I think with that, I hope everyone has a good night. And Uncle, can we stop the broadcast?
Sure.
Bye, everyone. Always a pleasure.